This is SpaceTime, Series 28, Episode 107, for broadcast on the 5th of September 2025. Coming up on SpaceTime, the brightest fast radio burst ever seen, the New Horizons spacecraft begins a record-setting hibernation period in the Kuiper Belt, and a new way to generate oxygen in space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected what they're describing as the brightest fast radio burst of all time. Fast radio bursts are ephemeral flashes of energy, often lasting just a few milliseconds, but capable of momentarily outshining every other radio source in its galaxy. These flares can be so bright that their light can be seen from halfway across the universe, several billion light years away. The source of these brief and dazzling signals remains unknown. But scientists now have a chance to study one fast radio burst in unprecedented detail. The burst, catalogued as FRB 2025-0316A, was detected some 130 million light-years away in the spiral galaxy NGC 4141 in the constellation Ursa Major. The discovery, reported in the astrophysical journal Letters, is one of the closest fast radio bursts ever detected, and it's also one of the brightest. The burst brightness, paired with its proximity, is giving astronomers their closest look yet at how fast radio bursts evolve and the environments from which they emerge. One of the study's authors, Yoshi Masui from MIT's Kavli Institute for Astrophysics and Space Research, says this fast radio burst is literally in our cosmic neighbourhood, thereby allowing astronomers to study it in exquisite detail. The clarity of the new detection is thanks to a significant upgrade to CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a large array of half-pipe-shaped antennae based in British Columbia. CHIME was originally designed to detect and map the distribution of hydrogen across the universe. But it turns out the telescope is also sensitive to ultra-fast and bright radio emissions. In fact, since it started operations back in 2018, CHIME has detected more than 4,000 fast radio bursts from all parts of the sky. But until now, the telescope hasn't been able to precisely pinpoint the location of each fast radio burst. That all changed when CHIME recently got a significant upgrade in precision. That was in the form of 3 outriggers, miniature versions of CHIME, each sited at a different location in North America. These telescopes work together as a single continent-sized system, which can focus in on any bright flash that CHIME detects, pinpoint its location in the sky with extreme precision. The new fast radio burst is the first detection made using this new array combination. It appears the burst arose at the edge of a galaxy just outside of a star-forming region. The precise location is allowing scientists to study the environment around the signal for clues as to what may have triggered the event. Now, while it's still a mystery as to what produces these events, the leading hypothesis points to magnetars. These are young neutron stars with extremely powerful magnetic fields, which can spin out high-energy flares across the electromagnetic spectrum, including in the radio band. Astronomers suspect that magnetars are found at the centres of star-forming regions, where the youngest, most active stars are being forged. The location of this new fast radio burst, just outside of a star-forming region, may suggest that the source of this burst is a slightly older magnetar. Masui says the precise localization of the burst is letting astronomers dive into the details of exactly how old a fast radio burst source could be. Now, if it were right in the middle, it would only be a few thousand years old, very young for a star. But this one being on the edge may have had a little more time to evolve. Now, in addition to pinpointing where the new fast radio burst was in the sky, scientists were also looking back through CHIME data to see whether any similar flares have occurred in the same region in the past. See, since the first fast radio bursts were discovered back in 2007, most have been one-off events, and that suggested a cataclysmic event such as the destruction of a star in a supernova. But a growing number of repeating fast radio bursts are now being detected, and that's pointing to a very different sort of origin. And there's another fraction of these repeating fast radio bursts that are flashing in a pattern, sort of like a rhythmic heartbeat, before eventually finally flaring out. So for now at least, the mystery surrounding fast radio bursts is whether repeaters and non-repeaters are coming from different origins. This is SpaceTime. Still to come, the New Horizons spacecraft begins a record-setting hibernation period in the Kuiper Belt, and scientists find a new, simpler way to produce oxygen in space. All that and more still to come on SpaceTime. NASA's New Horizons spacecraft has commenced a record-setting hibernation period as it continues its journey through the vast darkness of the Kuiper Belt. Mission managers at the Johns Hopkins Applied Physics Laboratory have confirmed that the probe has now safely entered hibernation mode at a distance of more than 9.2 billion kilometres from Earth. The confirmation signal required some 8 hours and 31 light minutes to reach NASA's Goldstone Deep Space Communications Station in California. It marks the start of the longest hibernation period in the spacecraft's history. It'll last until late June 2026, surpassing the previous record of 273 days, which was set between June 2022 and March 2023. The Kuiper Belt is a ring of comets, icy worlds and frozen debris circling the Sun beyond the orbit of Neptune. New Horizons principal investigator Alan Stern from the Southwest Research Institute in Boulder, Colorado, says New Horizons will continue to collect science data during its hibernation period using 3 instruments to monitor charged particles in the outer heliosphere and dust in the Kuiper Belt itself. He says that data will be stored on board and sent back to Earth once the spacecraft reactivates. Going into hibernation reduces operating costs. While in this mode, New Horizons spins in a stable configuration with most instrument systems powered down. Its onboard computer oversees health checks and transmits a weekly beacon tone through the Deep Space Network to confirm operational status. Since its launch back in 2006, the spacecraft has entered hibernation mode 23 times, ranging from a few days to many months. In 2015, New Horizons became the first spacecraft to visit the dwarf planet Pluto and its binary partner Charon, as well as their moons Styx, Nix, Kerberos and Hydra. Then, in 2019, it encountered the distant Kuiper Belt object Arrokoth, originally named Ultima Thule. And mission managers are now looking for another potential target in the dark outer reaches of the solar system. New Horizons is now some 9.27 billion kilometres from the Sun, and it's expected to finally exit the Kuiper Belt in either 2028 or 2029. This is SpaceTime. Still to come, a new way to generate oxygen in space, and the September equinox, as well as a tour of the constellations Capricorn, Pegasus and Cygnus are among the many highlights of the September night skies on Skywatch. A new study has shown that off-the-shelf neodymium magnets could help boost the production of oxygen in space to help support human space operations. A report in the journal Nature Chemistry claims scientists have used the magnets to help detach oxygen bubbles from electrodes in water electrolysis, the process of splitting water into oxygen and hydrogen. Now, this process generates separate oxygen and hydrogen bubbles on the electrodes. On Earth, these bubbles would simply float up and away. But in the microgravity conditions of space, there's no buoyancy to lift the bubbles, so instead they simply cling to the electrodes. Because of that, special pumps are used to deliver the bubbles to a centrifuge which can then separate the two gases from the liquid water. It's a complicated, energy-intensive system, and its unreliability requires astronauts to keep spare components on hand. The new research simply uses magnetism to manipulate the electrochemistry process. Now, you don't notice it here on Earth, but actually water has a slight tendency to be very weakly repelled by a permanent magnet. But in space, this tiny repulsion force becomes dominant. So the water moving away from the magnet displaces the gases, which are less susceptible to magnetism. Now there's also an interaction between the external magnet's field and those of the ions moving under the electrical field. Now, as these charges move in the liquid, the magnetic field induces an effect called Lorentz force, which steers the water's flow, causing it to swirl and move the bubbles to where they can be extracted. So, this new technique could eventually replace both the pump and the centrifuge. This is SpaceTime. And time now to turn our eyes to the skies and check out the night skies for September on Skywatch. September was the 7th month of the year in the old Roman calendar, which had just 10 months. That's before the addition of January and February. That 10-month year is still reflected today in the name September or Septem, being Latin for 7, October or Octo meaning 8, November and Novem 9, and December or Deci meaning 10. It really wasn't until the Gregorian calendar that January the 1st marked the start of the new year, but in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March the 25th, marking the Feast of the Annunciation and Easter. The earliest recordings of a New Year celebration are believed to have taken place in Mesopotamia around 2000 BCE, around the time of the Northern Hemisphere vernal equinox in mid-March. A variety of other dates tied to the seasons are also used by various ancient cultures. The Egyptians, Phoenicians and Persians began their New Year off with the fall equinox, and the Greeks celebrated it on the winter solstice. While the Jewish New Year, or Rosh Hashanah, the Festival of Trumpets, occurs in September, where it marks the beginning of the Northern Hemisphere cycle of sowing, growth and harvest, and apparently the creation of Adam and Eve, according to the Jewish Bible, the Old Testament. The September equinox will take place at 4:19 in the morning of Tuesday, September the 23rd, Australian Eastern Standard Time. That's 2:19 in the afternoon of Monday the 22nd of September, US Eastern Daylight Time, and 6:19 in the evening, Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equinus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun, and Earth's axial tilt is pointed to the same direction in the sky, regardless of Earth's orbital position around the Sun. So on other days of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. It's also worth noting that the solstices and equinoxes change, and they're impacted by what's known as precession. That causes Earth's spin axis to wobble ever so slightly, sort of like the axle of a spinning top. Now, the rate of precession is only very slight, just half a degree per century, so you don't notice it on normal human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit around the Sun the seasons occur, precession will cause a particular season, for example the Southern Hemisphere summer, to occur at a slightly different place on the calendar from year to year over a 26,000-year cycle relative to the planet's orbital position. At the same time, obliquity causes the angle of the axial tilt to change with respect to the ecliptic, that is, Earth's orbital plane around the Sun. Earth's obliquity, that is the tilt of the axis, is currently 23.5 degrees, and it's what's actually responsible for the seasons, and that varies over a cycle of roughly 41,000 years, between approximately 22.1 and 24.5 degrees. This axial tilt or obliquity changes due to the gravitational pull of the Sun, the Moon, and other planets. A higher obliquity leads to more extreme seasons, while a lower tilt results in milder seasons and can contribute to glacial periods. Then there's eccentricity. This involves changes in the actual shape of Earth's orbit around the Sun, sometimes making it more circular and other times more elliptical. This gradually shifts the point of perihelion, which is Earth's closest orbital position to the Sun. Now, these three effects, precession, obliquity and eccentricity, are collectively known as Milankovitch cycles, and they affect the amount of solar energy reaching the planet and have a major influence on climatic patterns. Okay, let's start our tour of the September night skies by looking towards the east and the constellation of Capricornus the Goat. The name comes from the ancient Greek tale about the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. The sudden appearance of Typhon scared Pan, the flute-playing goat boy, who tried to escape by turning into a fish and swimming away. However, he realized his cowardice before completing the transformation, and so distracted the demon by playing his flute instead. And this gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb or the tail of the goat. It's a near neighbour, located just 39 light-years away. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit across the universe. Deneb is a spectral type A white Beta-Lyra variable eclipsing binary. It's comprised of two stars closely orbiting each other. Now, astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red dwarf stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are usually about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As we mentioned earlier, Deneb is a Beta-Lyra variable eclipsing binary system. It's made up of two stars closely orbiting each other. The total brightness of the system changes because the two component stars periodically pass in front of each other as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of Beta-Lyra are massive giants or even supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives each of the stars in the system an ellipsoidal shape with extensive mass flows from one component to the other. Just below Capricornus on the eastern horizon, you'll see the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most beautiful-looking boy that ever lived, and so was carried from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way galaxy. Beta Aquarii, the brightest of the pair, is also known as Sedal Sud. It's a multiple star system, located about 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of our Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sedal Melik. It's about 520 light-years away, around 6.5 times as massive as the Sun, and some 3,000 times as luminous. Next, we move to the southern constellation of Pisces Austrinus, the Southern Fish. The brightest star of the constellation is Fomalhaut, the mouth of the Southern Fish, and the 18th brightest star in the night sky. Interestingly, thousands of years ago, it was used to mark the position of the winter solstice, the sun's most southerly position as seen from the northern hemisphere. But the precession of the equinoxes, which we talked about earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral Type A white-yellow star, about twice the mass of the Sun and around 16 times as luminous. It's also a really young star, only about 400 million years old. By comparison, our own star, the Sun, is some 4.6 billion years of age. Fomalhaut exhibits an excess of infrared radiation, indicating that it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral Type K orange dwarf star TW Pisces Austrini and a spectral Type M red dwarf star LP 876-10. Turning to the north now, there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus is the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning bolts for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's blurted out to a spectral Type K supergiant nearing the end of its life. Astronomers are still debating as to whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one of the corners of the Summer Triangle. It's also home to the giant Cygnus OB2 stellar association, which includes one of the largest known stars in the universe, MNL Cygni, a red hypergiant, about 1,183 times the radius and 50 times the mass of our Sun. In fact, were it placed at the centre of our solar system where the Sun is, its surface would extend out beyond the orbit of Jupiter. It's so big it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Now, Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964, and even today it remains one of the most studied astronomical objects in the sky. The black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Little wonder black holes are the densest objects in the universe. Located just above the northern horizon this time of the year is the star Vega. It's the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of our Sun, and it's a relatively young star, less than 500 million years old. And it's also fairly close, just 25 light-years away. Now, once again, due to the precession of Earth's rotational axis, Vega used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquila or Altair, the brightest star in the constellation Aquila. It's a spectral Type A white-yellow star with about twice the mass of our Sun. Altair is located really nearby, just 16.7 light-years away, and it rotates very rapidly, with an equatorial velocity of about 286 kilometers per second, and that's a significant fraction of the star's estimated breakup speed of around 400 kilometers per second. Now, this high rotation rate means Altair isn't spherical, but highly flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water-bearer for the gods. Looking to the southeast now, and you'll see the bright star Achernar. It's the brightest star of the constellation Eridanus the River. Located around 140 light-years away, Achernar has 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter being about 56% wider than its polar diameter. September also sees the bulk of the Origid's meteor shower, which is produced as the Earth passes through the debris trail left by the comet Kess C1911N1. Kess is a long-period comet, only reaching the inner solar system every 1800 to 2000 years. Its meteor shower runs between August the 28th and September the 5th. The Aurigids provide up to 5 swift and bright meteors an hour, with its peak just before dawn on September the 1st. It's best viewed from the northern hemisphere as its radiant, that is, the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. A second meteor shower in the month of September is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids should be confused with last month's Perseids meteor shower. That's because while both appear to have their radiant in the constellation Perseus, they're caused by debris trails from 2 very different comets. And now, with more of our tour of the September night skies, I'm joined by senior science writer Jonathan Nally. That's senior science writer Jonathan Nally.
G'day, Stuart. Yes, September evening skies, well, they begin with the Milky Way, which of course is our home galaxy seen from the inside, and it's stretching all the way across the sky from the northeast to the southwest as night falls during September. For those who live at mid-latitudes in the southern hemisphere like I do, we've got the centre of our galaxy more or less directly overhead as soon as the sun goes down, which is fantastic because this part of the Milky Way includes the star fields of Scorpius and Sagittarius, those 2 constellations, which is an amazing region of the sky for you to explore, even if you've just got a pair of binoculars. I mean, if you've got dark skies, and unfortunately most people who live in cities don't have dark skies, but if you can get yourself to a dark spot, then even just using your own eyes, you can just wonder at this amazing galaxy there above our heads. But if you can get a pair of binoculars onto it, then you can see a lot more. So Scorpius, for instance, is the constellation of the Scorpion. It's one of only a few constellations that actually look like what it's meant to look like a scorpion. Once you learn to trace out its stars, you'll see that they really do form the shape of a scorpion. Now, there are other constellations like Triangulum, which is a triangle, that sort of thing, which is not hard to make when you're just joining the dots of stars. But Scorpius really does look like a scorpion. It's quite incredible. Its brightest star, by the way, Antares, is quite bright and quite red, so it's really easy to spot. And to the naked eye, it looks very similar to Mars, if you've ever seen the planet Mars in the night sky. And in fact, that's where Antares gets its name from. It means the rival of Mars. And sometimes they're not too far from each other in the night sky, and then you can compare the 2. And they really do look quite nice together. And then that's where you can see that how it would get its name, the rival of Mars. There are some other bright stars around on early September evenings. Looking at it from a southern hemisphere perspective, which is what I have to do, we have Vega far in the north. We've got Altair in the northeast. We've got Arcturus in the northwest. Way down in the south, we've got a star called Achernar. And also way down in the south, we've also got the famous 2 Pointers stars. So Vega is the brightest star in the constellation of Lyra, which is named after the stringed musical instrument called the lyre. It's quite close to the star. It's only about 25 light years away, and it's the 5th brightest star in the whole night sky. The other one, Arcturus, so Vega's up in the north, and Arcturus is in the northwest at the moment. So Arcturus is the brightest star in a constellation you probably haven't heard of. It's called Boötes. That means the ploughman or the herdsman. And it's the 4th brightest star in the sky. And again, it's quite close. It's only 37 light years away, which is sort of nothing in space terms. Altair is even closer. It's only 17 light years from us. And it's the brightest star in the constellation of Aquila, the eagle. And it's the 12th brightest star overall. The one I mentioned down in the deep south, Achernar, yes, that's the sky's 9th brightest star. And it's the brightest star of the constellation of Eridanus, another one you probably haven't heard of. Eridanus is the constellation of the river, which is a very long, thin, winding constellation. It starts near the celestial equator and goes down to about minus 55 degrees, so it's 2/3 of the way down towards the south celestial pole. And right at the end of it is this star Achernar. Now, the other ones I mentioned, the 2 Pointers, are named as such because if you draw a line between these 2 stars and then just keep going for a little while, you end up very close to the Southern Cross. So they point towards the cross, the 2 Pointers, or the Pointers as they're sometimes called. Now, each of these is a triple star system. Beta Centauri is 360 light years from Earth, which is reasonably distant. But the other one, the Alpha Centauri system, is famous for being the closest star system to us. And one of its 3 stars is called Proxima Centauri, and it is other than the Sun, of course, it is the closest star to the Earth. It's only 4.25 light years away. And as I mentioned, the Southern Cross is not too far from the 2 Pointers. And at this time of the year, it's lying on its right-hand side when you go out in the early part of the evening. It's sort of probably about 20, 30 degrees up from the horizon, about 30 degrees up from the horizon, and lying on its side. Looks like a little kite. Now, if you have really dark skies, I was saying before, if you can get yourself to a dark location, you've got some dark skies, and you let your eyes adapt to the dark. So no looking at your mobile phone or anything, just get rid of all sources of light, get away from street lights and everything. Let your eyes adapt to the dark. See if you can spot right next to the Southern Cross a big dark patch in the Milky Way, just right next to it. This is a huge cloud of dust and gas floating out there in space called the coal sack, which is a good name for it, of course, the coal sack. And originally, a long time ago, people thought, well, what's this big, seemingly empty area in all these regions of stars? Is it a big hole that we're looking through to the other side? But no, it's not. Just a huge cloud of gas and dust that's blocking all the stars behind it. And there are a few stars in front of it. So, if you get a telescope in there, you can have a look around and you do see that there are stars in the foreground. But to the naked eye, it looks like a darkish patch in the Milky Way. Now, let's turn to the planets. As evening falls, the only one we've got visible at the moment is Mars, which can be seen in the west about a quarter of the way up from the horizon. It'll remain pretty much in that same spot all month long. And for all but the most diligent amateur astronomers, as I would call them, there's really not much point in trying to look at Mars through a telescope at the moment, as it's a long way from Earth and it appears really, really tiny. That's the problem with Mars, that it's a small planet, much smaller than the Earth, and it's a long way away, and sometimes it's near and sometimes it's further. At the moment, it's quite a fair distance away, and so it just looks really tiny. You can't see any detail on it when you look through a telescope. That's why astronomers wait every 26 months when we get to a point what's called opposition, where Mars is at its or closest approach. When Mars is at its closest approach, it takes about 26 months to come around every time, and at the moment we're not anywhere near that. So Mars is a long way away and it looks tiny. On the other hand, a couple of hours after sunset, we've got Saturn, which will be rising up over the eastern horizon, and it'll be the main target this month for planetary enthusiasts, at least for those up looking around in the evening hours. Saturn is much larger than Mars, so even though it is currently about 4 times further away than the red planet, through a telescope it still appears to be about 11 times bigger. So it's 4 times further away, but it still appears to be 11 times bigger because it's just a huge gas giant planet. So, and if you do have the opportunity to take a look at it through a telescope, please give it a try because it looks really quite specky. Everyone loves Saturn through a telescope. Now, for the night shift workers, insomniacs and very early risers, Jupiter is the next one. That'll be seen climbing up over the northeastern horizon at around about 3:30 a.m. or southeastern horizon if you're in the northern hemisphere. Give it a few hours to rise a bit higher so it's above all the haze and muck on the horizon. And then if you do have the chance to take a look at a small telescope, see if you can make out any of its atmospheric bands and zones. On Earth, we have we sort of do have atmospheric zones on the Earth, but generally if you just look at a satellite picture, it seems to be just a jumble of clouds and things. But on Jupiter, it's really the planet is divided up into sort of horizontal bands, and you can see them through a telescope quite often. You should also be able to see up to 4 of its largest moons, if they should be visible. These just look like tiny pinprick stars strung out in a line on one or both sides of the planet. They go around Jupiter, they orbit around Jupiter fairly quickly, so sometimes you might see 3 on one side and 1 on the other, or 2 on one side and 2 on the other, sometimes 4 on one side. Sometimes you might look and you might only see 1 or 2 or 3, and the 4th or the 3rd or 2nd one are missing. That's because they're around the other side of Jupiter and they're blocked from view, or they've gone into the shadow of Jupiter, and so there's no sunlight falling on them. So even though they might technically they'd be in direct line of sight and not behind Jupiter, they might be in its shadow, so you can't see them. Another morning stargazing target for September is Venus, which rises above the eastern horizon about an hour and a half before sunrise. Now, it's big and bright, and you simply can't mistake Venus for anything else. The only other things bigger and brighter in the night sky, or the daytime sky for that matter, are the sun and the moon. So you just can't mistake Venus. Mercury will be there too, below Venus, so closer down towards the sun, but it's smaller and not quite as bright, and it'll be a bit harder to see. And that, Stuart, is the night sky for September.
And this is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.